Now we'll do a few examples of translations. So basically there are two things we expect you to do. If I give you the function for a translation, I expect you to be able to draw the new image. In this case, I have the triangle here, ABC, and the function is x comma y goes to x plus 1 and y minus 2. So that means I'm going 1 to the right and down 2. So A goes down to this point here. B goes to the right 1, down 2, and to this next point. C goes to the right 1, down 2, to that point. Connect the points, and there you have your triangle. So drawing a translation given a function should be pretty straightforward. It's probably a little trickier to determine the function if I just give you the coordinates without a graph. So here you can see in this table I have the pre-image, the original, and the image, the final. How do I get from the pre-image to the image? Well, if you remember that x2 minus x1 that we use for basically the horizontal leg on the distance formula, it works pretty well here too. So basically I say, okay, x2 minus x1, 9 minus negative 3. That's 12. That means I'm going 12 to the right. Then if I have, I can do the same thing for going up and down. Do the second one first. 2 minus 7, that's going to give me negative 5. That means I'm going down 5. So I can basically fill in these points now, 17 comma negative 6, so that's adding 12 and subtracting 5. Going backwards is a little trickier. Instead of adding 12, I should subtract 12. Instead of subtracting 5, I add 5. Here I'm going to subtract 12, so it's negative 18, add 5 to negative 2, and I get negative 3. Here I'm going in the normal direction. Add 12 and subtract 5. Since it's 0, 0, it looks just like my rule. So for further reflection, how can you determine the function and the expression for a translation when there is no graph? Just go ahead and use the x2 minus x1, like we did in slope and in distance, and the y2 minus y1 for the vertical.